Okay, let's start by talking about the tangent graphs. We did this briefly in our parent functions last class. Given that f of x is equal to a times tan b of x, the period is what? Pi, which is the normal tan cycle, divided by this b. And we should make it absolute value just to know that that's the period. So if this is one cycle beginning at 0, at pi, it's going to start at 0 again. That's the next cycle. And these functions are all about quarters. So if I go halfway between these two, which would be pi over 2, I expect to find the asymptotic relationship that allows this to shoot down and this to shoot up. And if I go between negative pi and 0, halfway between those, is negative pi over 2. And if I were to go up one full pi from pi over 2, because that's one cycle, one period, that would give me 3 pi over 2. So the asymptotes are described as negative pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. In other words, they are the odd multiples of pi over 2. And last class, we talked about the notation for that. Do you remember how to force an odd number? Good. If n is an element of integers, negative 1, negative 2, 0, 6, 3, then you can do 2n plus 1, forcing it to be double, adding one more makes it odd. And then if we did that times pi over 2, that would work. Or we can distribute this through and we get 2n pi over 2 plus pi over 2. The 2's cancel. And you get n pi, which is a whole number value, plus pi over 2. In last class, we talked about amplitude and period, and I'm going to suggest that we do it a little differently than the directions here. We'll do it just like yesterday. So I'd like you to mark the amplitude and the period. This particular author didn't believe amplitude was important in tangent, and I'll show you why I do. What's the amplitude of this equation? Good, 4. What's the period? It's just normal, so it's pi, right? Since it doesn't have a sideways shift, we always start tangent at 0, 0, just like sine. And we know that a period of pi means that at pi again, it hits that 0 point again. And at 2 pi, it's 0. And at negative pi, it's 0. And at negative 2 pi, it's at 0. It's all about those quarter points. So halfway in between these, we can expect if this is pi and this is 0, this is pi over 2. This is our asymptote, our vertical asymptote. We'll have another one at 3 pi over 2. We'll have another one at negative pi over 2. Again, all the odd multiples of pi over 2. Now, in our previous work, just introducing the parent function of tangent, we recognize that if I go over halfway to pi over 2, what do I reach? What's half of pi over 2? Pi over 4, same thing as 45 degrees. And if I take the tangent of pi over 4, or the tangent of 45, what do I get? 1. Normally, my function would be at 1 and negative 1 here, and it would be this swooping curve. But because I've got an amplitude of 4, I'm multiplying that 1 by 4. In other words, instead of it just going up this steep, it's going to go up this steep. Instead of it going down this steep, it's going to go down this steep. Not very well graphed, but half points go up 4 this time and down 4. We did this yesterday without practicing it. We just did the parent functions. And again, in general, you want to have 2 full periods. Here I've drawn 3, so we're good. Questions? Try number 12. What's the amplitude? Yeah, we called it the absolute value of that. So it's really 1, but let's remember that there's a negative there because that's going to help us. What's the period? It's pi divided by 1/2, which is 2 pi. It doesn't have any shift horizontally or vertically. So we start at 0, 0. Just put it right here. And then since the period is 2 pi, we know that if I move forward 2 pi, I start over again. I'm back at 0, 0. If I move over here, I'm back at 0, 0. Again, it's all about these quarters. So let's go halfway between those starting points, midpoints. And that means that pi is going to be the asymptote, as is negative pi. Now, normally, we'd go halfway between this 0 and pi. So we'd go pi over 2. But normally, we'd go that up 1, wouldn't we? And then carry our graph up. Since we've got a lead coefficient of a -1, we have a reflection over the x-axis. So I'd go over pi over 2, down 1. And then left pi over 2, up 1. So we kind of flipped the slope on this thing, didn't we? Instead of it being a positive slope, it's now a negative slope. And again, we try to have 2 full cycles. So let's add in enough from these other pieces, going halfway over and down 1 to the right here. And from here, we're going halfway over and up 1. So it's coming like that. That's now 2 full cycles or periods. Take a look at 14 here. Please try this one yourself now. Right, let's take a look. What's our amplitude? Good. And what's our period? So it's full period of pi divided by 2/3, which is 3 pi over 2. That's a weird one. Okay. So we're going to start at 0, 0 because there's no horizontal or phase shift. We're going to go over 3 pi over 2, which is 1.5 pi's. And that's going to be the next start. 3 pi over 2 here is another start. I know that halfway in between these, we expect to see something important going on. So what's half of 3 pi over 2? 3 pi over 4. So that's this part here. And we know that in tangent between the zeros, that's where we find our asymptotes. And so I know that halfway between 0 and -3 pi over 2, which is -3 pi fourths, we'd also find an asymptote. We can actually see in this graph that if this is 1, 2, 3 spaces between the asymptote and the 0, we should be the same on the other side. 1, 2, 3 spaces. There's symmetry. So we can close one off here as well to finish our 2 cycles. And now from here, I'm going to go halfway between 0 and 3 pi over 4. What's half of 3 pi over 4? 3 pi over 8. And at that point, this has a lead coefficient of 3. So instead of going up 1, I'll go up 3. It's going exactly half the distance between the 0 and the asymptote. Half the distance. This is 3 spots. So I'm going to go over 1.5, which is -3 pi over 8 as a number. And again, try to get a second full cycle. Ideally, also labeling the axes. So let's see if this is 3 pi over 2. 3 pi over 2 from 2 pi is pi over 2 divided by 2 is pi over 4. So 3 pi over 2 plus pi over 4 is the same as 6 pi over 2 plus pi over. So this would be 7 pi over 4. No, that's not right. This is 3 pi over 2, and this is plus a fourth. Yeah. So this is the same as 6 pi over 4. 7 pi over 4, 8 pi over 4, 9 pi over 4. If I add those together, I get 15 pi over 4 divided by 2. This is 15 pi over 8. We'll play more with the fractions. Okay, step 2. Please flip to the next page. Yeah. Yeah. No, notes are not almost done. Okay. As I said, today we've got 3 topics. Tangent we just did. Now we're going to do transformations. We've already done the period and the amplitude adjustments. So now we're doing the translations left and right. Like other functions, trigonometric functions can be translated. Given the functions over here, the h represents a, you can think about it as horizontal, but in the world of trigonometry, it's actually called a phase shift. Whereas k represents a vertical shift. Because it has to do with cycling of energy, particularly like light and audio. Out of phase means out of sync, right? If you're trying to make constructive interference or destructive interference, if they have a different phase, they're out of sync. Vertical shifts. If you have plus k, what does that do to the function? Almost vertical. Up k units. And negative k is down k units. Positive h inside here would mean what? Good. Left h units, whereas negative h is right h units. It's backwards of what you expect in with the x. So for instance, down on number 3, if you see sine of x plus pi over 2, what would that do to the function? Left pi over 2. Whereas number 1, cosine x plus 2, move us up 2. Okay. Now we're going to talk about the midline. This is that point that runs right through the center, kind of the horizontal axis. Shifting a graph vertically will create a new horizontal axis called the midline. This is the reference line to which a graph oscillates. In other words, it goes up the amplitude from there and down the amplitude from there. The equation of this midline can be found by simply saying y equals k, whatever that vertical shift is. So let's look at number 5. What's the amplitude? 3/2. What's the period? There's a 1, so it'd be 2 pi. What's the phase shift? None. I'm not subtracting or adding to the x, so that's 0. What's the vertical shift? 3 up. And the midline? Y equals 3. So for this one, what I'd do is I'd give myself my midline. I'm going to draw right through that midline, give myself a light little mark. I'm then doing sine, and there's no phase shift, so I'm going to start at my normal spot, which is on the x-axis, or the y-axis, excuse me. My period is 2 pi, so if I move 2 pi over from that, I should complete one cycle. And it's all about these fourths. So I'll cut it in half. That's pi. In my sine curve, that's going to be a 0 point. Halfway again, this is pi over 2. That's going to be a high point for me. How high will I go from here? 3/2. So that's 1.5. So from this value starting of 3, it would go up to 4.5 up here. And then the other quarter point here, if this is 1/2, this is 2/2. So this is 3/2, 3 pi over 2. And I'd go again down 1.5. And it's really important that we start thinking about these in these even 4 quadrants. How many spaces in this case is one of those quarter quadrants? 2. So if I wanted to continue it this way, I'd go 2 back, put a dot. That's got to go down to a low. 2 back, put a dot. That's a middle. 2 back, that's a high. 2 back, that's a middle. How are we feeling? 5, this is working for me because I knew this before and I know the trig functions. 3, I know one of those. I either know the old transformations or the trig functions, but I'm having trouble putting them together. 1, I'm not sure what I don't know, but something's not working for me. Great, good scores, 4s and 5s. Okay, let's do this one. Amplitude. 1, period. Pi, good. Remember, tangent's a different period. Phase shift. Left, pi over 2. Vertical shift. Midline, y equals 0. So I know I'm dealing with a y equals 0 midline. That's good. Normally, tangent goes right here, dot in the center. But we've got a phase shift. So I'm going to move over pi over 2 to the left. That's my starting point. As always, I go 1 period from that. Period's pi. So if I go pi plus negative pi over 2, that's going to take me to pi over 2. Then up to 3 pi over 2. Back to negative 3 pi over 2. That means, because it's tangent, in between my zeros are what? Asymptotes. And then typical tangent, is that a positive slope or a negative slope? Positive. So coming from this 0 line, I go halfway to the asymptote and go up. Amplitude is 1. So just up 1. Go to the left and down 1. Left and down 1, right and up 1. Left and down 1, right and up 1. And again, I try to get at least 2 cycles out of it. Okay, the next page is more practice for you, including sine, cosine, and tangent. Please flip to the next page. And we're going to build the parent functions for cosecant, secant, and cotangent. Last piece for today. So the parent function here is going to be y is equal to cosecant of x. You guys intimidated? Good. This one's not hard. Cosecant is so closely related to what function? Sine. So here, to do these, I'm going to graph sine first. So sine starts at 0, 0. Oh, this is that axis. Remember, this is the one I like to change. Please change the scaling of the y-axis so that it's 1 and 2 instead of 2 and 4. So the sine starts at 0. It has a period of 2 pi, so that finishes again there. Halfway between would be another 0. Halfway between 0 and pi would be pi over 2. And I'd go up to a max. And I'd go down to a minimum here at 3 pi over 2. Just do this one lightly, because this is going to be a reference for our cosecant graph. And as typical, we want to see 2 cycles. So I see 2 spaces to get to the next critical value. So I'm going to go left 2 spaces, down to -1. Left 2 spaces, back up to 0. Left 2 spaces, back up to 1. Left 2 spaces, down to 0. Now I've got 2 nice completed cycles. Feeling okay with the sine part, right? Now, cosecant is how related to sine? 1 over sine. In other words, it's the y value that's 1 over sine. So here where we started at 0, what is 1 over 0?
It's undefined.
Undefined. In other words, I'm going to take all my 0 points and turn them into asymptotes because those points are now undefined. Sure. Colors help. Okay, what's the y value of this coordinate here? It's 1, right? What's the reciprocal of 1? Also 1. So those points stay the same for the new function. Cosecant and sine share those points. What's the reciprocal of -1? -1. So those cosecant and sine share those points. Now, if we really, really, really needed more points, we could visualize that, for instance, coming from 0, when we come over to 30 degrees, we could come up 1/2, right? Sine of 30 is 1/2. What's the reciprocal of that? 2. So I know that it's going to be up here somewhere, and it's going to achieve another one over here. But for our purposes, I'm really okay with you just showing these u's. You don't need to give me any additional points. When we talk about the critical values of the cosecant curve, we usually look for 5 in each of our trig functions. I would expect to see asymptote 1, asymptote -1, asymptote. That's 5 coordinates or 5 critical values. It's not so bad, is it? Okay, so what's our domain? Generally, we want to do all real numbers, except that there are some values that it can't be. Good. So not, yes, thanks. So not n pi, where n is an element of integers. What about the range? So we're going to go -infinity to -1 inclusive, union 1 to infinity. How about the x-intercepts? There are none. How about the y-intercepts? There are none. What about the asymptotes? Again, the same values that were excluded here would be equal to our asymptotic equations. amplitude 1, period 2 pi. What do you guess is going to happen when we move over here to secant? First, sketch the cosine, then do the reciprocals. Please do that now.
What?
I'll let you fill the rest of these in. But what are the asymptotes for this one? So we've got negative 3 pi over 2, negative 1 pi over 2, 1 pi over 2, 3 pi over 2. How do we express the asymptotes using odd multiples of pi over 2? Good. So x equals n pi plus pi halves, where n is an element of integers. All right, that gives you what you need. Please finish up this packet as homework 56.